Today we're starting a unit on what is called symbolic logic. Now let's think about logic. Thinking about arguments like the following. If you read the Times, then you're well informed. Statement 2, you read the Times, therefore you are well informed. Because if you accept 1 is true and accept 2 is true, then it follows that 3 would be true. So statement 3 is considered a conclusion. Now each proposition, each of these statements, can either be true or false, but they can't be both. I mean, like you either read the Times or you don't. And in symbolic logic, we like to use symbols to represent statements instead of always writing the words. So we're going to use some different connective symbols for things like and, or, not, that type of thing. So we're going to let P represent that John is 2 meters tall, and Q is that John plays basketball. So if we did not, and let's take the first statement, not that statement. So what does that mean? Well, if we negate it, that would be that John is not 2 meters tall. Or what would be the symbol for that? Okay, well there's a couple of different ways that we can write not in symbolic. Sometimes you'll see a squiggle. Sometimes you'll see this, and it just depends on what software they're using. So they would say squiggle P means not P or not P. Oh, I'm sorry. That would be the symbolic sentence. The symbol is either the squiggle or that. So if we're thinking about back when we had Venn diagrams, that would be, so if we had P and Q, not P would be everything on the outside of P. In symbolic, in Venn diagrams, that would be the not with the little dash. So let's negate the next sentence. John does not play basketball. Again, that's either going to be a squiggle, or depending on what software they use, this little sideways L thing. I like the squiggle. That would be not Q. So Venn diagram, you're looking at everything outside of Q. And. So if we connected those two propositions with and, it's a conjunction. John is 2 meters tall. Oops, I can't spell meters. Tall. And plays basketball. The symbol for and is this up arrow. So it would be P and Q. Well, doesn't that kind of remind you of the intersection symbol? P and Q, you're talking about the intersection of the two. Very similar. So we would have, what is it, that. Well, that's similar to that upside down V there. Or, John is 2 meters tall. Or he plays basketball. Or is this symbol. So P or Q. What was that in the Venn diagrams? Well, that was the union of the two. So is everything in here, including where they overlap. And I think the symbol we used in the Venn diagrams was the union of P and Q. So for symbolic logic, it's a V, and here it was a U. So part of what you're asked for is to write statements using symbolic logic, And you have to clearly define each set of the propositions. So on part A, so if we say Tom is taking math is one part, and Mary is taking a physics course is the other part. Let's call this T and this M. So Tom is taking math and Mary is taking a physics course would be T and M. Anne is passing math, but she is failing English. Well, if you do that, Anne is passing math, would be an M. What if we said that E was her passing English? So that would be M, but failing, but not English, or and not English, because she's not passing English, and so forth. So let's go ahead and go to this one where they're already defined for us. Good math students go to good universities. Good music students are good math students. Students who go to good universities get good jobs. So from these statements, what would be two valid conclusions? Well, you could connect the first ones and say good music students go to good universities. You could also say good math students get good jobs. Or couldn't we connect all three? Good music students make good math students who go to good universities who get good jobs. So couldn't you say good music students get good jobs? Now what would the squiggle Q give us? So that's the symbol for not. So good music students are not good math students. The upside down V was the and. So P and R. So that means good math students go to good universities and students who go to good universities get good jobs. Notice that when you're using the symbols and writing down things, this is not where you make valid conclusions or skip anything. You're literally writing down each statement with the connector. So what if we're given the statement and want to write it symbolically? So P is that Sherlock Holmes is alive. Q is that he lives in London. Sherlock Holmes is alive and he lives in London. So that would be P and Q. Either Sherlock Holmes lives in London or he's alive. Now this is an interesting one. He is neither alive nor does he live in London. So what would that really mean? Let's think about that. He's not alive, nor does he live in London. Could it be both? No. So, not P and not Q. It is not the case that Sherlock Holmes is alive and he lives in London. Notice that this one is stated differently. It is not the case that. So these are grouped. So Sherlock Holmes is alive with P and he lives in London We should have done this one as an order. Sorry about that. It is not the case that he's alive and he lives in London. Not the and. Okay, so sometimes those do get a little complicated. So a lot of times we use truth tables to figure out all the possible outcomes. So let's start with the and, both P and Q. So suppose you're offered a position at a firm. They require both that your applicant must be at least 18 years of age and that Q, an applicant, must be a college graduate. So to get the job, you must meet both requirements. So let's think about all the different options. Well, the first option is that you are 18 and a college graduate. Do you get the job? Yes, you met both requirements. What about if you were 18 but not a college graduate? So the first statement is true, the second one is false. Well, that would be, you're not getting the job because you have to meet both requirements. What's another option? Okay, what if I'm not 18 but I do graduate college? Am I going to get the job? No. What about the last option would be that you're not 18 and you're not a college graduate. Does it meet both of them? No. So a conjunction, the and, is true when both are true. So you have to have true, true to get a true. Now the or, the disjunction, really means either P or Q or both. Remember, it's the union of those two sets. So when they simply say or, in symbolic logic and in Venn diagrams, that means P or Q or both. There's actually a different symbol if it doesn't include the both. So if they said you must meet at least one requirement, then would you get the job if you were 18 and a college graduate? Both truths. Of course you would. What if you're, so we're going to list out those same options that were up top. I'll just go ahead and fill those in. So let's look at the next scenario. You are 18, but not a college graduate. If they had an or type statement, would you still get the job? Yeah. Because if they say you must be at least 18 years of age or be a college graduate, have you met one of the requirements? Of course you did. What if you're not 18, but you did graduate from college? Well, you're smart, but yeah, then there you go. What if you didn't do either? You are not going to get the job. So this disjunction, or is true when at least one true. So let's look at the negation. Well, that's pretty easy for a truth table. If your statement was true, the negation would be false. If the statement was false, the negation would be true. Now, I know this one says try it, but we're going to do it together. So let's say P represents that Jones passed this course, and Q is Smith passed this course. You know, actually, let's pause the video, and y'all try it, and when everybody's had a chance, then continue the video. And let's see if you get it right. So, in symbolic form, neither Jones nor Smith passed the course. Neither Jones nor Smith passed the course. It is not the case that Jones and Smith both passed the course. not the case that they both passed. Now, what does this one say? Jones did not pass the course, or Smith passed the course. So we need to look at what the symbols would be for not P, because they're telling us that Jones did not pass the course. So false, false, true, true. So when it's an or statement, you're looking for at least one true. And we're taking not P or Q. So you're looking at these two columns. Remember, with an or, we're looking for at least one true. True, false, true, true.